In this video, we're going to take a look at the Model Mania Design Challenge from SOLIDWORKS World 2004. If you're unfamiliar with Model Mania, it's a design challenge that's held every year at SOLIDWORKS World where users are given a drawing similar to this. And they're tasked with creating this part in SOLIDWORKS both as quickly and as accurately as possible. Now, if that wasn't enough, when they're done with this part, they're given a second drawing with a series of design changes that need to be made. This particular year of Model Mania posed some interesting design changes, so we'll look at those in depth later on in this video. But we want to go ahead and start by modeling this part. It's very simple initially. It's really comprised of two main features, these two extrusions, almost like layers on a cake. But you'll notice what's unique about these is the shape on the top is defined by these radiuses. So we'll have to make sure that we capture those. This height in particular of 50 millimeters is just a reference. That distance is really defined by the center of these two arcs. So let's go ahead into SOLIDWORKS and take a look at how we model this. There's several ways you could go about doing this, and we're going to look at a few different variations, one on the first feature and a different one on the second. But I'm going to start by simply drawing the top profile. Now, this part is symmetric from left to right. So one of the things I like to do is to draw a center line whenever I'm working with symmetric parts. It always comes in handy. And when you want to create symmetric geometry on either side of a center line, a really easy way to do this is to pre-select the center line and choose dynamic mirror entities. When you do this, SOLIDWORKS puts a couple of hash marks on the end of the center line to know you're in this mode, but what's really unique is what happens. When you draw a piece of geometry on one side of the center line, SOLIDWORKS automatically creates the same piece of geometry on the other, and it will always maintain the symmetry between them. So for example, if I move the endpoints, notice they always move together. Likewise, if I draw a line from, say, this endpoint to the center line itself, SOLIDWORKS doesn't actually create two separate lines. It conveniently turns that into one continuous line for us. And finally, if you create a piece of geometry that would be identical, that crosses the center line so it would fall on top of itself, SOLIDWORKS recognizes this and says it won't create the symmetric element, but instead just creates the one single arc in this case. Once that's done, you can turn off dynamic mirror entities, and you may want to clean the sketch up just for convenience. I'll use power trim and just remove the end of that line. Now the next thing we need to do is add some of the defining dimensions here. The width of the part is given as 125 millimeters, and we're given a length. Now we conveniently have the endpoint of a line here at the tangency, which we could dimension to, but alternatively you can dimension to the outside of an arc at any time by holding the Shift key. Notice SOLIDWORKS updates the preview of the dimension in that case. Then all we need to do is place the dimension, and it's already 100 because we had previously set that. We'll add the radius to the front arc here of 75 millimeters, and the last thing we need to do is define the angle of these lines. Now if we go back to the drawing, notice where the angle is set. It's on the outside of the part where there's actually no geometry. If we go back to SOLIDWORKS, we could do this a few different ways. We could actually just invert the angle to the inside, but there's a new way of doing this in SOLIDWORKS 2015 that's really convenient. If you dimension to a line and choose the endpoint of a line, SOLIDWORKS presents you with a quadrant selection, specifically for dimensioning angles. If you choose the arrow in the direction you want to place the angle, SOLIDWORKS allows you to place that without having a piece of geometry there. That's really convenient in cases such as this. Now we've got our profile, but if you remember, this is actually extruded up to a radius. So how are we going to do this? Well, in this first example, I'm going to go ahead and I'm going to simply choose to extrude this some arbitrary value. 100 is more than enough. We know actually that the reference dimension is 50, so I'm going to go well beyond that. And what we're going to do in this case is we're going to cut that curve on the top using a cut revolve. Now, in this example, we're going to go ahead and draw this arc over on this front plane. I'm going to start by just creating a 3-point arc. I'm going to go from the outside edge to the outside edge, and we'll drop this? We know a few of the dimensions. For instance, we know that the radius of this arc is 160 millimeters, and the center of this is 120 millimeters off from the bottom. Now when we do this, look what's happened. Our arc is not fully defined, and in fact it's tilted to the side. You can see this. We can move this around. Now there's a few ways of solving this. The first one is you could select the center point and the origin and make them vertical to one another. An alternative way to do this is you could select the two endpoints and make them horizontal to one another. So either one of those ways will work. Now we do need to close this profile off, and again you could draw 3 lines, but another really quick way you could do this here is you could just draw a rectangle from corner to endpoint and just simply delete that extra line. Finally, because we know we're going to revolve this, we might want to add our axis of revolution. So to do this, I'm going to add a construction line, and I'm just going to place it, and then I'm going to locate it on the center using a midpoint relationship. You could have just drawn it out to the side, but I like to make sure that it's always going to be symmetric. So with that sketch profile in place, we're going to go ahead and perform a cut revolve. So let's go ahead and choose cut revolve. And I'm fine with it going 360 degrees. But notice what's going to happen here. It cuts through the part in a way in that it will leave the material we want on the bottom, but also this extra material up on the top. Well, SOLIDWORKS handles this using multi-bodies. When you press OK, SOLIDWORKS says 2 separate bodies will be created from this. We could leave them both, but in this case we only want the bottom one. So SOLIDWORKS gives you the option to choose selected bodies. When we do this, you can see that by selecting these, you get a preview of which body is which. And in this case, we only want to keep this bottom body. And now when we press OK, SOLIDWORKS removes that top body for us automatically. So there's the first main feature of our part. Now, the next feature is very similar to the last. If we go back to the drawing, you can see that its shape at the very top is offset 25 millimeters from that original profile. Now let's go back to SOLIDWORKS and take a look at how we could do that. We're going to draw a sketch also on the top plane, and we want to reuse that geometry or offset it. What you can do at any time, you can go back into a feature and select that sketch, and in this case we're just going to choose to offset it 25 millimeters. Now it's going the wrong direction, so we'll choose reverse and then press OK. But look what's happened here. We actually don't want it to stop at this line. We want it to continue to the back of the part. So in this case, we'll choose convert entities on the back edge, and then finally using our trim tool, we'll clean this up. This time we'll use corner trim, and we'll just grab this line and then that same line in the opposite side. When we're done, we can just simply remove that extra piece of geometry. So there we have exactly what we're looking for in terms of shape, but we need to capture that same type of arc on the top. And here we're going to look at a few different ways. If we go back to the drawing, you can see that these two arcs are 10 millimeters apart from one another. So if we go back into SOLIDWORKS, we could do the math and simply choose to offset that from a surface. An easy way to do this is to double click on the surface and then to select it and then choose offset from surface, and we'll set that to 10. And we'll reverse the offset to the outside. So there's one way we could have handled this. So pretty easy to do it that way. Another way we could do this is the same way we just did before. We could extrude it up to an arbitrary value and then create a cut revolve. What I want to show is a method called hybrid modeling. Sometimes creating surfaces are a convenient way to go about doing this. In this case, we're going to go ahead on the front plane. We're going to create geometry very similar to what we just created before. I'm going to draw an arc, and now notice what I'm going to do. I'm going to snap it down here on these edges because I always want this arc to fall on the outside of that part. So now see what happens. Those outside points always stay coincident with that outside edge. This arc does share the same center with the original sketch. So let's go ahead into that feature now and turn that sketch on. And all we have to do is drag the center point to the center point there. Let's go ahead and select the two and choose coincident. And then finally, we'll specify our radius, in this case 170. So now we're not doing any math, we've actually defined it by that radius. This way, if it changes, the radius is the important value, we can always change it if need be. Now, you'll notice all I've done is drawn a single line. What we're going to do is, instead of doing extruding the original sketch and then cutting it, we're going to go ahead and create a revolved surface this time. Now we need an axis of revolution, and I left that original sketch on to show a point. You can select a sketch entity from an existing sketch. So in this case, we've gone ahead and we've chosen to revolve this. Now, you can let it go 360, or you can change the angle in this case. It really doesn't matter because we're only using this surface for a piece of reference geometry. Now we're done with this sketch. We can select it and hide it. So that's one way you could have done this. You could have also drawn the sketch from the right-hand profile. But what I'm going to do is now I'm going to show different ways you could use surfacing. So we could do like we did before. We could extrude this up that arbitrary value of 100 millimeters, and you can use a feature called cut with surface. And when you do this, you're going to look for an arrow. Everything to the outside of that will be removed. So that's one way we could have done that. Let's hide this to show exactly what we've done there. So there we've got our shape. But in this case, that's not what I wanted to do. So I'm going to undo this. And this time I'm going to choose that sketch, and I'm going to show you can extrude up to that surface. Now notice what it did. It extruded up to the surface down on the bottom here. We'll just simply choose to flip the direction and go to the top. And we'll go ahead and press OK. Now we're done with this surface. You can go ahead and choose to you could delete the surface if you wanted to. So you could right click on it, and you could delete face. There's also delete body. I'll grab it out of the feature manager tree. It's a little bit easier. You can choose to delete it and get rid of it completely, or you can simply choose to hide it. It's your preference. I do prefer to delete them more often than not. So we have our two main shapes. The last few things we have to do are quite simple. If we go back to the drawing, you can see there's this 15-degree draft that needs to be added to the two different steps of this part. But what's interesting is where the draft is defined. If you look at the top view here, you can see that the top edge of that center feature needs to be maintained 25 millimeters from the outside. So let's go back to SOLIDWORKS. By default, when you create a draft inside of SOLIDWORKS, it uses neutral plane, and a lot of new users default to this. Neutral plane works great in cases where the edges happen to fall on that plane. But in cases where these faces we want to draft don't, look what happens. What SOLIDWORKS does is it defines the draft as though those faces extended all the way down to that face. So it's not exactly what we want in this case. Let's edit that and look at a better way to do this. Instead, we're going to choose a parting line draft. And with parting line draft, you choose the edge where the draft starts, and a little arrow is presented showing which face will be drafted. Now in this case, all the correct faces were selected automatically. Now when we go to the top, if we choose the top edges, SOLIDWORKS will retain this edge and it will draft those other faces outward. So you can see how convenient that was to get exactly what we needed. Finally, there's some fillets that need to happen to the part. There's nothing really special here, so I'll just go through the process of selecting the edges we need. Now I accidentally selected a face. That's not what we want, so I'll deselect that and choose the edges instead. So there's our 10 millimeter fillets, and then finally there's a few 6 millimeter fillets that go along the outside. Now a lot of times I like to grab faces, but there's a problem grabbing the face. It looks good here in the front, but look what happens in the back. SOLIDWORKS will fillet all the edges on that face. That's why I'm choosing edges in this case instead of faces. Now you could use this face right here and get very similar results, but if I'm already grabbing an edge on the front, let's just go ahead and grab it here. Plus it might create an error later on that I want to show how to fix. So I'm specifically setting myself up for a problem with the change. Finally, there's a wall thickness to this part of 4 millimeters. We're just simply going to do this using a shelf feature, and I'm going to select the back and bottom face of this part to get what we need. So there you have it. There's phase one of this part. Now at this point during Model Mania, users are presented with a second drawing. This drawing has a major change to it that really changes the overall look and feel of the part. This 20 millimeter and 20 degree slope that inverts the direction of that top piece creates a whole new set of challenges. Other than that, most of the dimensions have been left the same. So this is a pretty significant change. Let's look at it in SOLIDWORKS how we can tackle this. One of the things that I like to do when presented with a radical design change is to simply roll back to the beginning of the part. And what we'll do is we'll look at our very first feature. In this case, nothing really needs to change how we created this first primary feature, both the extrusion and the cut revolve. Now, the next set of features, this surface revolve and this boss extrude, do change significantly. And conveniently enough, we did happen to use surfaces, and that's what we're going to do to make this change. Now, like before, there's several ways you could handle this. I'm going to show one using surfaces because that's what we've already done here. I'm going to roll back, and you can't change a revolve surface to a planar surface, but we can create a new one. What I'm going to go ahead and do is capture that angle by drawing on the right hand plane. And I'm going to draw a line just from somewhere on this back edge out to the front. Now, a thing you might want to do here is snap to this edge. Now, the reason I did that is notice what happens. It'll always extend the full length of the part. No longer, no shorter. The same thing actually happens here on the back. Then I can just go ahead and add my dimensions. It's 20 millimeters off from the bottom edge, not 200. Let's change that. And there's an angle of 20 degrees off from the bottom edge. So this is actually the edge or the angle we want to extrude up to. Now we're going to do something very similar to how we created that feature. We're going to use surfaces and use an extruded surface. For simplicity, I'm just going to make sure that this extrudes through all in both of those directions. So now we have another surface. If we go into our feature manager tree, you can see that both of those surfaces actually exist in this part. We're not going to need this one, but before we go ahead and delete it, let's make a quick change. All we're going to do is instead of extruding up to that revolve surface, we're going to select the sloped surface instead. And it makes that change quite easy. Now at this point, we don't actually need this surface anymore. So I'm going to go ahead and I'm going to choose to delete it. Now notice if you don't check delete absorbed features, it'll leave the sketch behind, which we don't need anymore either. So in this case, we've gone ahead and extruded up to the surface, but that doesn't fix this back area. Well, one of the things you can do in SOLIDWORKS is you can reuse sketches from features, and I'm going to choose to reuse this sketch because it has the profile I want. The problem is when I choose to cut with this sketch, it's down here at the bottom. So for example, if I said I wanted to cut up to surface, it's actually going to remove that material. Well, SOLIDWORKS has a great option in the extrude features up here at the top called the From option. And here you can choose an offset. And in this case, I'm going to offset it 100 millimeters up above the part. So notice what happens. My cut actually starts up here and cuts into the part from the other direction. So that's a really convenient way to do that. Like before, we're really done with this surface. Now before I hit it, I'm going to show you here that you can actually go into the feature manager tree, and if you really know you won't need a surface again, you could always delete it as well. That way those folders don't show up with extra surfaces and you might not know what they're there for later on down the line. So we've made the most drastic change, but I'm wondering how it's affected our other features. Notice when we roll down past the draft that the feature has a warning. That's because these edges have been completely redefined that we selected before. SOLIDWORKS is showing us that 3 of the edges are missing. Now you could go through here and you could select and delete these and redefine them. That's one way of doing this. The other way is to simply select the new edges and disregard that, and SOLIDWORKS will remove them when you confirm the feature. So like before, the draft starts out here. Now notice inside there's a draft that starts from the bottom and drafts outward. Well, conveniently, parting line draft allows us to do this all within one single feature. So really quickly, we're able to get there. Let's continue to roll down and see what happens. These front fillets have no problem solving, and then we get to this fillet and we have a similar problem to what we had before. This top edge is now missing here, or it's been changed enough that it needs to be redefined. What we're going to go ahead and do is we're going to edit this feature, and this time I'm just going to leave the missing edge, and what I'm going to go ahead and do is we need to add a fillet to the insides here. And you'll notice when I grab this top edge, the preview goes away. That means that it can't be solved. I'm going to go ahead and just deselect that for right now. And in this case, we'll just add an additional fillet. Now keep in mind the missing edge. Notice when I press OK, SOLIDWORKS says that some of these are missing. Yes will automatically remove those. So you can actually avoid the need to go back in and delete those. So in this case, we're going to go ahead, we need to copy this fillet. In this case, I'm actually just going to hold my control key down and I'm going to drag a copy of this fillet out onto this edge right here because I want it to retain the exact same values. And there we now have the fillets that we're looking for, and finally rolling to the end, the shelf solves without any incident. So as you can see, we looked at several different ways of creating the initial part. And we also using surfaces as kind of a hybrid modeling technique, and we also use those surfaces in phase 2. So hopefully you enjoyed this Model Mania Design Challenge from SOLIDWORKS World 2004, and be sure to visit the SOLIDWORKS World website where you can learn more about what's happening this year.